Hello, and welcome again. And thank you. And thanks to Farah for setting these breakfast sessions up. I employed Farah, and so I am somewhat obliged to follow what she says. I do as I'm told. This is the fourth in the series of breakfast talks, but I'm not convinced that I landed the most interesting of subjects, building engineering. So I suggested that it might not be such a bad idea to liven up the title a bit. So I suggested, but she wasn't having any of it. But she didn't want that either. So one step further, but again, it wasn't to be the case. So I've been left with something that looks a bit like a Quentin Crisp parody. Anyway, onwards. Building engineering. What's it all about? And like on those pseudo-documentaries, I'm obliged to give this disclaimer. Sorry. The glib answer, of course, is that building engineering is what keeps me and my 450 colleagues upstairs in this building very busy indeed. A large proportion of you ask us to collaborate with you in your building projects, and it's that keeps us busy. We're not the only ones either, as some of our competitors have caught on with this building engineering idea as well. But what actually do we do? And what do they do? Who are all these people? But let's put that to one side for a moment. I studied as a structural engineer, UMIST and Imperial College. So I looked at building engineering as a course at these two august institutions. It's not quite true, as UMIST doesn't really exist anymore. And although I could find many references to other engineering courses, I couldn't find one that was called building engineering. So, is it something to do with the words? Are we constructing, as in building, some sort of edifice to engineering itself? Building engineering? And I am conscious that sometimes we have been said to create problems where there aren't any, just to keep ourselves busy, but let's not go there. But no, really. It's about providing the engineering design of buildings. So perhaps we should have called ourselves Engineering Buildings. But that has an acronym of EB, and EB has already been taken by others. The terminology was, almost inevitably, invented by Ove. The idea of a multidisciplinary team then being required to design a project. It was thought necessary then due to what was seen as a fragmentation of the design industry. Those that attended Nigel's talk might well remember him speaking of the term total architecture to describe Ove's goal. It was the tenet behind the formation of Arup Associates, the complete multidisciplinary team, including QSs. Total architecture, note the word architecture, not engineering. But that might explain who building engineers are and where the name came from, but it still doesn't get to what they actually do. It's probably easier to explain it using a negative. Building engineers do what the architects don't do. And if I were to ask an architect what would be left standing if you took away the architecture from the building, you'd probably say nothing, because absolutely everything is architecture. And when the engineer starts talking about the volume of the space, the orientation of the building, the shape and position and even colour of the windows, then he's pretty much talking about the whole thing too. So we're left with one of those annoying mathematical inconsistencies, whereby 100% and 100% of the building still equals only 100%. Those of you that were also here for David Healy's talk on the Shard will hear of his reference to St. Paul's and Christopher Wren, and his friend Robert Hooke, who helped him a bit with what we would term today the engineering of the dome. In the 17th century there was just the architect and his friend, but even Hooke called himself an architect, as well as a philosopher and a polymath and lots of things as well. And it's quite clear, therefore, at this time nobody recognised engineers, let alone building engineers. Our renowned learned societies didn't even exist. If we go back even further to Roman times, we have Vitruvius. Not only didn't he have any engineering friends, but he was slightly fearful of even publishing his ideas and thoughts on architecture. Should it distract from Caesar's engagement inquiring the right to command the world? Clearly someone who thought that architecture was a world-changing issue. But publish he did, and in his 10 books on architecture he expounded on the necessary education of an architect, which was, quite simply, all-encompassing. And some of the subjects he touched on in this education, lime, pozzolana, stone, timber, rainwater, acoustics, climate, were terms that today we would probably consider technical. There was also astronomy, but let's put that to one side. But perhaps even then there were some architects who were better at some things than others. Some who would already be specialising. Maybe some more aesthetic compared to others, perhaps more technical. The amphitheatre specialist, perhaps. Or the forum specialist. Maybe there was even a forerunner to Arup lighting. So, we have gone from the one-man show, through Christopher Wren with a little help from his friends, to Arup and his ideas to deal with the fragmentation of disciplines, to today. Today, where it is not just about structural, mechanical and electrical, or quantity surveying for that matter, we have fire and facades, acoustics and access and AV, we have lighting and logistics, we have kitchen consultants and people flow consultants, we have waste and vertical transportation, we have sports specialists, we have theatre consultants, we can go on and on. An aside for a minute. There was a story some years ago about a design meeting concerning a certain well-known architect's own front door. Not this one. And the meeting had 13 different design consultants present. There was a similar meeting about his library and the stair that accessed the books. Anyway, it is often said now that we live in a technological age, and technology is there to make things better, easier, safer, more efficient. But the better is the key word. Key, otherwise, what's the point of doing things? And the word better brings with it its own complexities. And those complexities breed disciplines. Then we find ourselves with a long list of specialist consultants that you can see here. So one could say that building engineering has become a means of dealing with this continuing fragmentation of the design disciplines, all associated with building projects. Building engineering ties it all together. But fundamentally, today's issues are very similar to yesteryear's. Engineers didn't exist per se then, so maybe they don't today either. Maybe building engineers are actually technical architects in disguise, a flip side to architecture. And things have evolved that way so as to make things better. The different technologies of our modern life demanding it. And as an aside, I often wonder whether we could design and build the Empire State Building today as quickly it was done then. Somewhere between 13 to 18 months to build. Just a thought. Some of you may know that a lot of my early engineering experience was based in France. The French are very proud of their engineering, amongst other things. But funnily enough, it's not usually associated with buildings. The TGV, the Mont Blanc Tunnel, the Eiffel Tower, Panama Canal, the Millau Bridge. There is some resonance there with early British engineering history, but I believe it still exists in France today. You could say that the French view of engineering is, shall we say, far purer. And perhaps the compromise required in building engineering, due to all the pushes and pulls from the different disciplines, leaves them slightly uncomfortable. It gave me the impression when I was there that building engineering was almost a dirty word. It didn't carry the same respect as other areas of engineering. Sold their soul to the devil, if you like. Real engineers don't eat quiche. And if we were to talk in the same vein about architecture and purity, would we have art at the pure end of the architecture scale? And if you have art at one end of a scale and pure engineering at the other, perhaps architecture and buildings is where they interact. It's where people come into the equation. And it's delivered by architects, and some of whom might be of that technical type that we mentioned before. So perhaps the most important component of what building engineers do is the buildings bit, as opposed to the engineering. It's therefore probably more logical to put buildings before engineering in the title as we do. It also explains a bit, perhaps, why we've evolved as we have. We're trained in individual disciplines, but we're interested in all the different components of buildings. The building structural engineers are interested in the mechanical systems, etc., etc. There is a technical linkage in that they're all engineers, and an interest linkage in that they are all interested in buildings. And one day, perhaps, they all hope to understand what an IT comms engineer does. Both Einstein and Buckminster Fuller were said to have made similar quotes relating to knowledge. In buildings, all the disciplines contribute to make their bit of the project better. What building engineering does, or at least tries to do, is bring all these fragmented disciplines together into one team, so that we revert back to the time of the singular architect. Nowadays, the necessary knowledge no longer resides in one person. We talk often about a team approach, and a team made of very different disciplines, but all with the same interest and goal: buildings. Not everybody wants this team approach. Some people prefer the absolute purity of being the uncompromised specialist. Me? I'm a team person, and that's why I took up building engineering as a career, and I think this applies to most of our people too. We get the buzz of interfacing with different ideas from people trained differently. The successful team is often made up of all sorts of different shapes and sizes. Each respects what the other does. The teamwork is something that leads to success. We must be doing it reasonably well, otherwise we wouldn't exist, or be as successful as we apparently are. And it does lead to some pretty spectacular things. Originally, we saw the benefit of building engineering as coordination. Inasmuch as it can be, because there'll always be human error, coordination is a given these days. Computerized drawing became normal as opposed to something special in the late 80s. 3D software and 3D modelling has been the standard for almost a decade. So what we do as building engineering isn't just about coordination. The challenge is to get the different engineering disciplines working together so as to go further, to stitch back together the fragmentation and make more of it. It's like 1 + 1 = 3. Facades and mechanical systems are a good example. I apologise in this case for an old example. We designed the CMA CGA Tower in Marseille 6 or 7 years ago, but it's taken a long time to build, but that's another story. In looking at detail at the facade mechanical interface, we were able to use, here in Marseille, a chilled beam solution, probably for the first time in that sort of environment. It helped achieve a facade the architect wanted, and it helped pass the latest French energy rules, as it was actually far more efficient than the typical fan coil solution. Happy architects, happy-ish clients, but for other reasons, and this is just part of the story. There was also an interaction with the lighting, the security and the access systems. So there were therefore happy engineers too. Building engineering also seeks to improve efficiency. The building across the road. Not ours or that one that's on the construction site, but the other one. In integrating the structure and service to a 450mm zone rather than adopting the separate discipline layer approach, an extra story has been possible. It's nothing new, but probably even more value than a few years back. Camp Sark in Riyadh is another example of the integrated thinking that permeates building engineering. The form is designed to turn its back on the sun, protecting both the building itself and forming courtyards. Transparency in the facade is introduced on the north side, facing into the courtyard, allowing views out whilst excluding the damaging southern sun. Openings on the south side are small, designed to allow sufficient sunlight to daylight the interior. And it will be complete in 12 months' time, albeit what seems to be like a rolling 12 months' time at the moment. And there is also energy efficiency, though to be honest, my thoughts on this are still developing. The building we are in here today has a capacity of approximately 1,350 people. Gas, electricity and water bills for the last 12 months total £295,000 for the building. That's £220 per head per year. It's a lot, but is it really? Is it enough to make decisions on? There was probably about £25 million worth of mechanical, electrical and facade installations in this building. So how does the discussion go? If you spend so much on changing the technical specification, you would then save 10% on the running cost? 10% of £295,000? It's not really enough to make a decision on. Energy costs would need to rise, but I can't see that as a strategy for winning votes at the next election. Or legislation needs to change and we become obliged to do things. Or, and there are signs of it happening, It's seen as an important differentiator for certain clients. The quality markets are interested, not quite philanthropy, but an important part of their corporate branding. As a comparison, I also added up the same costs for my own house. I live with my wife in a terraced house in London. It's a bit of a TARDIS, really. There are just the two of us now, and the costs last year were £1,600 per annum, or, with the two of us, £800 per head. But we do consume a lot of electricity. My wife melts glass in an electric kiln, which she probably wouldn't do if we still had our 3 boys at home. So if there were 5 of us instead of 2, and no electric glass melting, it would be £320 per head. It's an interesting number for you to take away with you, and not that different from the building we're in now. So £200 to £300 per head per annum. Technology is one of the drivers of building engineering, and it should also be liberating for architecture. Pritzker Prize-winning architect Jean Nouvel once tried to explain it by saying that you don't need to see the engine of a super sports car to know that it is modern, fast or high-tech. You can just see it in the integrated whole. You know that technology has hidden what it needs to under the boot. He felt that rather than being constrained by technical architecture, the advances in technology were actually liberating him, helping him to do things he wasn't able to do when he started his career. But if technology can liberate architecture, where can it lead to? For some, it means that buildings get more efficient, as we have seen. With others, it is new architectural ideas that are allowed to develop. With new things, there are also often critics too. Just because you can do it doesn't mean you should. I often use the example today, we can just about do anything. This building again, where we are, weighs about 14,000 tonnes empty. And if you have foundation issues, suspend the building on helium balloons. That's a helium balloon of about 240 metres by 240 metres by 240 metres. 240 metres? Well, that's the length of the Hindenburg. Archigram even proposed it some decades ago. New architectural ideas deserve to be explored. Personally, I find it very exciting. Building engineering is very important in this, as it managed to group all the necessary technologies needed together. And it gets built. An art gallery put Bilbao on the map. And not just an art gallery, something totally different. A new architecture. It's been termed the Bilbao Effect, and now lots of people want one. It's seen as a differentiator. People come from all over the world to see it. Even I went. Bilbao wasn't one of ours, but Metz is. Towns used to collect art in art galleries, but when a Monet costs $80 million, and you can have a Metz for €50 million, and you can design your own, different, unique, and not have to bid for it at an auction. Towns and cities collect architecture now. Is that the new art? And it certainly draws the crowds. And if people like it and flock to it, isn't that a wider sustainability? I like these sorts of projects. They also test us. They push our boundaries, help us to find new limits for the integrated skills of all the disciplines. We don't necessarily know where this real-life research will lead us, but things do come out of it, and not just non-stick frying pans. Most of these new directions are being explored in 3D, and 3D buildings require 3D modelling. An example, if you like, of how the technology and the desire interact. Just like an art gallery, you create a space, and an artist will find something in it to inspire him and to react with. And when we push the 3D boundaries, it also has the effects on other things, increasing our overall knowledge base. Building engineering, or the assembly of all the disciplines, is key as the number of interactions multiply dramatically, and you need people skilled in looking out for this. So where will all this lead to? Vitruvius, to Wren, to Arup, to today? It all says things will get far more complicated, and I'm certainly not going to vote against that. There will be yet more new disciplines. So it's either the time for the Uber project manager who can bring all these disparate threads together, or the designers need to do it themselves, and it's getting harder. Architecture will also remain a differentiator in the future. Clients and their clients will want things that are different, but nonetheless that benefit from a sameness of approach. There will be more new architecture, and clients will see it as a benefit, but it needs the right sort of discipline and disciplines in the team to deliver it successfully. And it's not just clients. Design and build used to have a bad name. Now, innovation of design team is quite normal. It's accepted. Contractors have delivered outstanding quality and value in many areas for years, yet there's still been a stigma relating to design and build for certain types of project. It's disappearing. Just as trade breaks down barriers between countries, the desire to do better by incorporating the contractor in the team will lead to yet more new ways of doing things. We, here in this country, have some of the best clients and project managers in the world. I travel a lot. I meet the competition, if you like. And we will all get our act together on BIM as an industry. It's not there yet in my view, but when we do, it will lead to step changes in what we all can deliver. So how does building engineering fit into this future? Well, building engineering is at the heart of all these things I've just mentioned. And despite, or maybe because, of harder times are making us better at it, it's the constant evolution, if not revolution. And the next step for the revolution? Let them make cake. And preferably one made by building engineers. Thank you.
I thought it was a classic, running through the relationships between architects and engineers. I think things have evolved a lot over the last sort of 20, 30 years. People understand the need to work together and to get the maximum out of engineers and all their disciplines. You need to be totally open and collaborative and draw on those ideas. You add them together and you end up with a much better architecture as a result.
Well, it was interesting having met Paul a month ago and not knowing what to expect. That his talk very much complemented the one on the Shard, and it was an excellent view of how a combination of different disciplines come together to deliver the whole. And that's what I was just saying to some other people here, that it really does require a combination of engineering skills across the board. And without one, it won't be complete. So, no, excellent talk.
I think the main thing that came out of it for me was the holistic approach to buildings and engineering, which is something our company strongly believes in as well. And it came across from Paul very well. If you have lots of fragmented, small disciplines working together, how on earth can you expect them to work and pull together the design in a way that a company that can, an organisation like Arup, has those multidisciplinary expertise. So yeah, it was very good.
I found it very enlightening. We were just saying actually how nice it is on a cold morning, to sort of get the brain geared up into more sort of ethereal thoughts, thinking of life and the future, and it's excellent.
Well, we, as German-British Chamber of Commerce, we promote trade and investment between Germany and the UK, and so we're interested in promoting particularly energy efficiency, which is a big area in German technology, and Paul's thoughts on energy efficiency, the whole engineering of buildings is very relevant for us, and I'm pleased to see that it's not only a German thing, but it's an international topic that is of growing relevance to people.
I thought it was great. It was sort of different to the previous sort of Shard, more technical and more sort of philosophical. And a different view. And he's so right about all those different aspects of engineering coming in and increasing in number. So, no, I thought it was very good, very interesting.